Hi, I'm Jim. Welcome back in my series on putting new aluminum fuel tanks in my Merlin GT. This section I'm going to cover the filler cap, the filler neck, some of the other accessories that you weld on the outside of the tank. Before I get started, I'll remind you again, I'm not an A&P and I am not an expert machinist, okay? So when I make these, you'll see some stupid things and I'll try to point them out, but you know, just a guy, you know, working on his home built here. So I looked at aircraft spruce and, you know, a lot of the caps they had, you know, not for use with auto fuel and things, which is what I run. I run auto fuel and I'll run E10 and, you know, no big deal. And I looked at Summit Racing and this and that. In the end, I just got annoyed. And one of the things I wanted to do differently on this tank was give a little bigger diameter to the filler to make it easier to see in the tank and see where the level is, especially as it fills. That last little wedge fills up pretty quickly. So what I decided to do, I decided to order some 2-inch aluminum pipe. I think I got that from Speedy Metals. 2-inch ID, I think it's a Schedule 40. I ordered some bar stock. I have access to a lathe and to a mill, so you know, why not just roll my own? So that's what I did, and that's a lot of what we'll cover in the video today is machining the threads, machining this cap. You get to see some of my bozo moments. O-ring from McMaster Car, some other bits of bar stock for the bungs, for the, you know, fuel inlet, the vent, the sump. I ordered some plate stock make some reinforcing rings to go underneath the fuel tank sender. Okay. One comment on that, because I didn't record any of this. You may know this, but this 5-hole pattern, the holes are not spaced evenly. Once you put it on the ring and use a transfer punch and mark all the holes, it only goes one way. You can't, you know, clock it and put it in a different direction. It's just a one-way fit. So you want to make sure that it's setting in the right direction in the tank for the float to work. Okay. And this just welded on, drilled and tapped it. I did run the screws all the way through, and I put some Loctite thread sealer on the threads of the screws so they don't leak. And this got welded on, those got welded on. So with that, I guess we'll get to work. I will say before we actually show you something useful, or at least entertaining. I hope it's at least entertaining watching me bumble around on the machines. At this point in time, it's been in the airplane for several months, and I put quite a few hours on it, and everything is going well. So with that, let's get to work. Okay, so I'm setting up to make the filler neck for the tank. I got this, I think it's Schedule 40 aluminum, 2-inch pipe, so it's 2 inches on the ID. I'm going to thread the inside and then make a cap. It's going to be a non-standard thread size, but that's life. So the first thing I want to make sure is this is straight in the chuck. And so I got the indicator there, and so it looks like I got a high spot here, and it's low somewhere here, so high spot was there. I don't have a plastic hammer here at work, so, oops, too much, definitely too much. Tighten this up a bit. Let's try that. High spot. Low, some of it's not totally round. And here is actually the low spot, and then the high spot somewhere right here. So that's more tube roundness, I think, than actual screwed up. Let's look at the inside, I guess. Yeah, I don't think I'm going to get it much better than that. It's just not that round. I know that the threading tool angles are square with the back of the tool, because that's how I ground it. And I should point out, I am not an expert when it comes to machining, more of a doof, so yeah, whatever. I'm going to run 12 threads per inch so I can go at any number on that dial. I did check that just to be sure. I think, so I got it, it's basically at 0 now. I'm just going to run it in just as a practice run. 55 RPM there, 12 threads per inch. Gauge that. Okay. And when it gets into my 0, I crank it inward. So I'm waiting for my number to come around here, engage the half nut, watching my dial here, it'll go past 0 and come around the second once, in, and stop, bring this back to 0, rinse and repeat. Whole turn, I forgot a step. Okay, that's back to 0. Okay, now it's making, here's my 0, and I need to come in this way. Four thousandths. Okay, I told you I don't do this very often. And I'll engage on the first number that comes around. And watch my dial down here. Okay. Yeah, not much of a cut, but I wasn't planning on that. Just this comes back to 0. Alright, I'm back on the dial indicator. I can bring it into, take up the 10 thousandths there. Okay, so there's my thread. I'm going to call that good for the thread. I'll put a chamfer here for the O-ring and a chamfer there just to get rid of that garbage. Sorry about the shaking. And then we'll make a cap. Okay, so there's my threads. A little gritty, but I don't think they're too bad, considering that I don't know what I'm doing. So we'll cut it to length and we'll have a filler neck. Okay, so I got to make the fittings for the fuel drain and for the vents and stuff. This is 1-inch OD, and I got to put a 3/8 pipe tap into it. So I'm going to square it off, center drill, usual routine. Okay, a braver man than I would power tap this, but no. And a smarter man than me would have bought a legitimate tap follower last time he was at the tool store. You know, this lathe got donated to my lab here without any tooling particularly. So as I need things, I just buy it, and then now it's available to the students. And I guess I didn't think of a tap follower, but I'm using a center to keep it straight in the hole. Once you get more than a few turns, it's going to be straight. Just got to be able to pat my head and rub my belly at the same time. Okay, cut it off on the bandsaw, stick it back in the lathe, face it off. Nothing exciting, so I don't think I'll record any of that.